Unknowingly,
from the
Disclover
shadows.
he is in the presence of an unseen predator.
I
For
did see Mr.
hands,
Yeah,
we
go
got
for it.
we got Mr. Zave for hands. Peter has his hand up as well, but I think he's talking, so I think he's good. And that's it. That's all I see so far. Oh, and Ken has his hand up as well.
Man, I don't see anybody's hand.
See my boy Plucci Cast. I think I said that right. Hopefully, my boy No Globe Dominic. Shout out to your boy, dude.
Yeah. What's wrong with Dominic? You going Plucci cast
The
on him?
only hand I can see down there
Plucci.
is a guy named Barber Dan.
Is that not his name?
Barber Dan?
Dominic and
Mr.
Plucci
Xavier.
cast or whatever.
But now I'm seeing
Plucci.
people pop up.
Plocky Cast. Oh, it's Plocky. Dude, it's Plocky. Oops. I said Plucci.
Oh, and I'm not gonna.
Yep.
I can't be around you. You're gonna influence my pronunciation in a negative fashion.
Sorry about that. Yo, dude, so I went to try and learn that one guy's name that I mispronounce all the time, and I've said it wrong so many times that I can't. It's permanently.
Dude, I know. On Globebuster's set yesterday, I watched you try to enunciate, and this is what he did. His name is.
You must be talking.
Didn't even try. He just like.
Dude, how do you make a Twitter poll?
Never met her.
Do you have to have like premium or something to make a Twitter poll?
No, just make a tweet, and then there's one little spot on there where you can make it a poll.
I'm trying to make a tweet, and I don't see a thing for a poll.
What do you want it to say? You tech.
Oh, here it is. I have to do like the big one. Okay.
Could you type a little bit harder? Look, the harder you type, the more that the poll is going to get voted on.
Dude, that's crazy. You can hear my keyboard, dude. This how can I adjust this? Does Twitter even allow you to do that?
Well, when you're not talking, you mute it. That's what you do.
I just have a quick thing I wanted to add on Schrodinger. I kind of solved his issues. I think he had talks with Lesbos.
I'm glad that you hung in there for that long on that one, No Despair. I'm glad that. Listen, that is some quality janitorial work if I've ever seen it.
Man, I just want to point out that no one cared that he stuffed a cat in a box for a week and didn't.
I love how that was the starting premise. I love how he so accurately was like, "Yeah, you guys like cats?" That's exactly how it started, right? Historical fact. Who's got cats in here, right? Guy was like trying to do a trick.
Yeah, like a week prior, he set up Bring Your Cat to Work Day. Didn't tell any of his lab assistants.
He's like, it doesn't matter. It's a fictitious cat, right? The point is, it's a duality cat.
Say, Karen, let me see your cat real quick. Check something out.
Let me show you how dumb your belief is, right? This thing is simultaneously dead and alive, but you won't know till you think about it, right? It'll pop into existence at that point. Sits you up for the double slit, and you're like, cool. So it's a particle wave, depending on how you feel.
Oh, is that the one that changes based on observation?
Yeah. There's that dude.
That's a mood ring. I think you're thinking of.
Dude, the funniest meme is that little monkey guy, right? Looking through like the glass, but he's like looking awkwardly at the camera. And the first slide is him looking through, and there's more things.
Here, we'll take I'll leave the poll up for like how many minutes? 5 minutes, just to get everybody in here that's listening to take it. I want to see like what people in here think. Is light made of photons? Are photons real? Or is light a wave?
If you put it in here, we're just gonna post it to the internet.
Did anybody ever found a photon?
I mean, do you want me to put a longer time on it? Because I was just going to do it for the chat. Like, I would have to put a longer time because 5 minutes, the internet's not going to get it.
I've got a photon in a box. The only issue is, as soon as you observe it, it
goes away.
It's no longer there.
Yep.
Just trust me, bro.
Okay, so I'm going to share this.
Put it up there in the Jumbotron.
Yeah, I just did.
Is that what I sound like with a fan on, or is that just Nicolas Cage?
Both.
Oh, come on. I turned it off.
You can hear my fan?
Well, yeah, not now, right? But it's been known to happen.
I mean, never, not once in the history of man, but like memory hold that shit. Like, listen, there's never been fan noise. All right, these aren't the droids you're looking for.
These are not the fans we're looking for.
This is not.
All right,
I
we're up to
learned
a whopping
to-
4 votes. What an active audience.
Oh, where can I find poll? Where do I go?
No one even knew you started.
It's in the jumbotron. If you
Up
just
there.
go into like the space, like the chat that we're in, and go to the 10th thing at the top that slides with post in it, it's the very leftmost post.
You can see it says, "Is light made of photons?"
Did you make it gay? Yes, I love point particles. Nice. I have to choose that if you believe it, though. Okay, guys, no cheating.
I voted the yes one.
Oh no.
You cheated. You ruined the whole thing. That's 3 demerits and loss of rank.
Oh, I learned two new fallacies that you guys might enjoy. What is appeal to altruism, which is when when you're arguing with someone and they're like, oh well, surely if your scientific theory has merit, Ruhif, then it would rise to the top because science is all about bettering mankind.
Oh,
So
what
that's
is that
called
called? Appeal to altruism? You mean like, oh, if you already disproved relativity, how come you don't have a Nobel Prize? You mean like something like that?
Yeah. So I was looking into it because I always thought it was like fallacious to say like, oh, surely, if it was good and the goodest scientific theory, it would rise to the top, the cream. So that's called appealing to altruism. That's a cool one. The other one is tone
Thanks, man.
policing. It's a fallacy called tone policing. That's when, someone ignores the argument but instead goes, "Oh, why are you so mad? Why are you yelling?" And it's like that's also a fallacy. So
Appeal to tone police? Is that a real thing? That's a
it's called
too-worthy
tone.
contribution.
Yeah, appeal to altruism and tone policing fallacy.
Okay, everyone
So you
remember
guys can
those?
enjoy
Mark those
those.
down. Remember to use those because those happen all the time.
And what's it called when they start throwing out word salad? Word
Appeal
salad.
to insufficient vocabulary.
Nick, are you saying when they start claiming that you're using word salad?
I know that one, Brian. It's appeal to gullibility of the audience.
Is that for you or what?
I think that was an attempt at a joke, but often when Globers try to meme, you can't be sure, right?
I know. I was like, I don't know, man. Were you saying you're gullible?
Well, that's a good question. It's a tricky one.
Hey, what do you guys
I
think the
think
mathematical relationship is between Glober anti-charisma and lack of ability to meme?
it's a strong correlation.
Is it linear? Do you think it's parabolic? Like, what would you guess?
Parabolic.
Yeah, you think so? Like extreme, like so would increase to near infinity, you think?
Yes. Yes.
Yeah, me too. Me too.
Yes. But the word salad fallacy is where you prey on the gullible audience and your own followers also being gullible, including yourself. It's like a circular
Peter,
or
I'll,
gullibility circle jerk.
I'll be honest with you. There is preying on people, but it's not followers. It's people like you, right? We lure you in here. We talk to you. We use you for stuff. We put you in front. We make you say, like, like we do use people, but it's not the people who follow us. Anyway.
I have to say that the word salad term, I think it's very 2023. In 24, we've moved on to a different term.
I think, Peter, that's not word salad. Word salad is like incoherent babbling.
Yes.
What you're talking about is appealing to the other person's ignorance or ineptitude. So you have the wrong definition.
No, I had something else in mind. I like to use the term glossolalia, speaking in tongues, is where you utter nonsensical syllables, but you do it so convincingly that the audience is into it.
I never thought about it that way. Thank you for contributing that, Peter.
Have you ever seen like a video of someone speaking in tongues, like in a church, and the audience being like agitated and like enthusiastic, and the more they wind themselves up with the glossolalia, then the audience participates even more and more. It's kind of like that.
You know what, Peter? You might be right.
Shared
I think I am.
information.
Yeah, it's profound.
It's based on almost 1 year of study, so it better be.
Wow. Well, the
profound.
longer you study, the righter you are. I've seen that graph somewhere.
Yeah, I like that one.
Yeah, it's definitely true. Never seen it prove wrong once.
I don't know.
Anyway,
I kind of entice people to use the insult, oh, you're using word salad. Frankly, I wear my badge with pride now that I've earned it, because to me, it is a twofold admission. One is obviously the person hurling the accusation saying, hey, you're using word salad. That guy clearly doesn't have a grasp on requisite nomenclature and is telling the other person that, and at the same time complimenting on the other person for their superior level of knowledge.
but like somehow socially shaming their intellectually superior opponent, at the same time virtue signaling to other intellectually inferior people who give them pats on the back. Like that's the part where I get confused, like socially acceptable part.
It
It's a
is
very
quite
complex
nuanced.
dynamic.
Yeah.
Like, oh, did you get word salad? Oh, come here, come on, it's okay. Oh, did he intellectually embarrass? Oh, you didn't read enough books as a kid. You don't know the words. That's okay. It's okay. We have a club. Everyone feels the same. We meet every Thursday. We'll get over it together, or whatever. Like, that's not what should happen. Like, if my buddy got embarrassed, I'd be like, bro, you should read a book. Like I love you, but like, read a book. In fact, isn't that how Alan started or whatever? But it wasn't, it wasn't a friend who was vindictive learning.
I hate learned or whatever.
Spite learning until you love learning. That's how you do it. You
Yes.
spite it until you love it.
All right. We're up to 17 votes at my count. And I think the no boys are carrying this one over the line.
What a drastically unexpected turn of events.
Yeah, quite.
Let us show the internet where all 17 of us have concluded with a 70% majority.
No, you can't have 17. They're gonna. You can't have 17. They're gonna think it's like a Q conspiracy, dude.
Speaking of that, dude, shouldn't there be another W drop right about now? Shouldn't we have like our leader be giving us these like cryptic more tidbits where we can establish truth or whatever? You guys aren't following the W drops?
Who should be dropping that?
Well, obviously you don't know. It's the W, right? We don't know who it is. We don't know if someone whose name starts with Witsit. W. Jesus.
Gotcha. Well, he did put a post in the Mitzwitch channel just the other day saying that we should be expecting some content soon.
Nice. I really want to push the W post conspiracy, both to further our cause, but also to clown on Q a little bit, and as a third result, to really show the effectiveness of that sort of plan, because I think we can do all three of those things.
Watch the flatness of the water.
Dude, put that out there right now. Watch how many people find flatness where there is none. Well, what else we got? No despair. Ralph's been thoroughly destroyed. I think he's still hanging on up here with a mic. I think Peter, Xavier. What you had to say?
Oh yeah, go X.
Yes. How's my mic coming in? Was glitching on my other account, so I figured let me just swap over.
Sounds good, Zave.
Yeah. So, in light of your poll, I just thought of something, right? They don't look at it as a dichotomy. They don't think particle or wave. They think particle that acts like a wave, i.e., their wave packets via quantum mechanics, right? So we know it's fluff, we know it's BS, but that's how they can have their duality, right? That's how they can have their paradoxes, right? It's not just them. There's some flat earthers that that have the idea that the wave is nowhere. Sure, we can vote that poll and say light is a wave, the electromagnetic waves, but a wave of what, right? A wave is nowhere, as our friend said. It's a probability wave. It's a wave of probability. You're gonna need a flat Earth for that. Alan does it better. Alan does it better. We're gonna leave names out of it, but
Holy
but
crap,
but
that was
we've had
great.
discussion.
I thought I was doing it.
We had some. Sorry, snacks. We had some infighting with this before, so it's not enough to. I think when we say agree to disagree, it's a low key fu. You know what I'm saying? It's like I don't feel like going back and forth. We're just gonna have to agree to disagree, but we know we're truthers, right? If we can get down to a truth and false of a matter, let's provide evidence and say why something is true or false, right? So what's going on with this dead cat and it's alive at the same time? Past that stuff you guys are smoking because that sounds crazy talk. That sounds like crazy talk. So let's see if we can get down to something. Alan can chime in later if he wants, but he helped me research something that I found interesting, right? On the behavior of these wave, quote unquote, wave packets. I put in the nest the polarizer paradox in conjunction with a property of Bell's theorem. We understand if we let these electromagnetic waves pass through certain filters in a certain orientation, no light gets through. No light gets through. And if we reorientate some of these filters, light will get through as if it's bouncing and ricocheting off the patterns of said filters. Well, wait a minute. That sounds like an actual thing. Ricocheting, so more light passes through, the more you reorientate these filters. Oh, that's an actual wave. That's not a wave of probability. Doesn't sound like this wave is nowhere to me. So when we talk about these things, there has been experimental data that we can find that could narrow it down. That we don't have to say this stuff is nowhere, so it becomes a problem. Like Piezo rightfully pointed out, you can't have a zero-dimensional point, right? Shout out to Bev, flat earther. We introduced the point paradox to him a long time ago, where you have to refine that definition. Maybe it could be the smallest measurable point, measurable area that has dimension, but it can't be zero dimension. You can't have a thing where you can say it is nowhere. What is it? And the only things that are nowhere are ideas and concepts. Is this like love, where we use it colloquially that something exists but it's nowhere? It doesn't have location. No, we're talking about electromagnetic waves here. Physical things that have physical properties. Can't be nowhere. Can't be absent location. So I put that in a nest. If any of you who've seen such the paradox and how it's fixed, it would give credence to light being an actual wave and not a wave of probability. I'll end it there for now.
Dude, you tried to quote Nathan Oakland. I mean, you tried to use his voice, and it made me immediately think of. You guys know he did an episode on our Reds and Thing rhetoric. He didn't show his audience any of the ether stuff, but he was surprisingly positive of our endorsement. And I woke up one day and was like, "Oh, I have 73 notifications from people saying Nathan Oakland sent me." So, not what I expected, and really cool. But your crazy imitation of him made me think of that. Sorry, what you said was super on point and relevant and awesome as always. Also, you talked to Bev? Easy.
Yeah, unfortunately, I had the honor of talking with Bev. He loves his horizontal planes. I mean, hey, that's a start, I guess. I wish he could just move forward.
Yeah, no, he has to be
Let us
the
not
big special
forget.
one.
Horizontal is perpendicular to vertical.
Listen, go get your Dadian Gratum and make sure that it has an actual perpendicular orthogonal value to it, okay? I'm gonna need you
For
to
the
do some
medium
homework.
or outside of the medium?
Listen, outside the firmament doesn't matter, flat around, you know what I mean? That parabolic reflection, how you gonna get your arc? Listen, you can't word salad with me, bro. You're gonna start saying some dumb shit. I'll say some real shit and still be funny.
I have a good word salad if you guys are up for it.
No, you have 3 words that you learned from me one day when you were awestruck, and then you've been repeating them ever since. I said them all 3 at once one day, and you were like, "Ah!" And that was it.
I do remember the specifically. So
Yeah, actually, I copyrighted all 3 of those words in that order. Since you've been saying them, they've been infringing my copyright. So, do we have real people who want to talk? What about Sad Dog? Good Sad Dog up here. Never talks. We got Mister down there. Let's start making people uncomfortable. Who wants to come up?
I think Flat Earth Dave is trying to sleep to us.
I think he's probably trying to not sleep while stubbornly blaming us for him not being asleep. Probably. What do you guys think?
yes.
Yeah, money on that. That's awesome. Who else? So now we just have cool flat earthers left. Oh no, the Swahala's down there. You guys want to talk to Swahala?
I mean, the question is, do you want to talk to him? You know?
Is that a Ruhif, but like, a little bit more relaxed?
He's a fierce Ruhif cheerleader, so I can see the confusion, right? Plus, there's that Aussie thing where they just instantly support each other. It's like a virtue signal, but worse or whatever.
Swallow, get in there, buddy. I'll get on your side. I'll argue with you against them.
Nah, maybe he's just listening tonight. Could be out to dinner again. We got our boy Dominic down there, though. Let's get him up here. I like talking to him. Dude, spreading the word in a totally different country, doing it up. It's also good to know that the stuff that we peddle, the stuff that we bring up, the show, the research, right? He's taking it and weaponizing it to a totally unsuspecting crowd. That's like if time was real in an actual dimension, you can go back in time and go to like a war when they're shooting with like swords, and you bring like a Gatling gun, and you just like mow down a whole lot of people. That's what I envision Dominic is doing with like ECEF and ECI reference frame arguments over in the Czech Republic. Dude, they're like, what?
I heard he debated as an astronaut, and the guy defecated in the middle of the debate, and they had to edit it out and sign a disclosure.
Yeah, I heard the subtitles they forgot, so you can actually see, shit his pants in the thing when the action happens.
I said this to Stone already, but do you guys know what the formal name for hand wave dismissal is?
Is it Riff? Well, what is it?
It's appealing to the stone.
I don't get it.
Just hand wave dismissal. So like,
It's the fallacy of appeal to the stone, where you just dismiss something as absurd without explaining the absurdity.
Oh, they do that all the time to us. Like, they'll put like a nice post with math and explanation, some dynamics, some kinematics, and they'll just be like, "Ha, stupid," right? The whole, and it's like, oh, astounding rebuttal.
yeah, I just got bored. I was looking up.
Yeah, they don't really it's like when they ask you for a source, TM, it's like they don't really want you to go get a source. This is what we found when we present sources all the time. Like, they just want you to be wrong, right? So go get your source just means I'm betting that you don't have one. And then when you present like lists of segregated subcategory lists, They'll do anything they can to dismiss all of it. If you remember, there was a nice little episode we had with, I forget what his name, Kyle from NASA. We put a post about GPS and satellites, and Kyle, actually, his first response was that exact thing. He was the incredulity guy. He put the big long math about the Earth's name, and he was like, haha, no. Right? That was the big response from Kyle at NASA. So, of course, I was like, finger crack, here we go. NASA, Kyle, what's going on, right? Here's some stuff. It's some reading. Gave Kyle some homework. I gave him a list of papers that supported what I said. He tried 7. He instead chose, instead of addressing this list, he responded 17 tweets of attempts to dismiss, discourage, discredit, or otherwise not look at this list of 17 accredited papers. In the end, he picked one paper that was published from a less than reputable source and used that to discredit and smear the whole list and was like, aha, victory. Of course, but, in the public eye, I was like, Kyle, if this is the best we can expect from NASA, then I don't think this is going to go very well. But like that's a good example of exactly what like, no, I'm a Kyle from NASA. This dumb on the internet can't be right. And then literally like, oh, but I didn't expect you to support with a whole bunch of lists. What is this, academic papers? What do you mean? Like, it's like, so like what they don't do is read all the papers for the sources in a logical anticipation to see if they can't like get a refutation to the argument. They're not like, whoa, a valid counter. They're like, oh shit, get it away. My eyes, right? It's weird. Because if we were presented that, we would read it. We would read all the papers and be like, "Oh shit, papers that don't like. Let me see that. Let me add them to my collection." Right? It's so different. Dude, who was it just the other day when we were like, we need some exclusive evidence for the flat Earth, and I was like, cool, here's some. Right, I got some got some interferometry measurements of exclusive motion that doesn't comport with it. And he was like, other glober across the bar. When I was in his face with the nose waving evidence, he was like, isn't it crazy how they don't have any exclusive evidence? Like, bro, I'm right in front of you. Could you stop ignoring me and stop talking to the other globers so you can circle jerk about you don't have the thing that I'm trying to show you? That's the mentality, right? They'd rather just grandstand on the fact, like if you present the thing they're asking for, they can no longer grandstand. So it's not as fun, right? So they just pretend not to notice. I'm just here to say a thing, but
Shane, you want to know something amazing? You know how?
no, I prefer to live in ignorance.
Sorry, you go ahead and continue your thing if there was more to get on to the end of that.
No, I just prefer to live in ignorance. So when you want to teach me an excellent thing, my first inclination is no, right?
Yeah,
of course not.
No, I know what you meant by what you said. I was just apologizing in case I interrupted. So you know how C equals F lambda, frequency and wavelength multiplied together?
Yes.
You know how that gives you the speed of light?
Yes, right. So we got like the permittivity and permittivity of the background properties of the vacuum itself, giving you the speed of light. Yeah, sure.
So, did you know that that relationship, works for light? What do you think about sound? Do you think it would work for sound?
I think it would work for sound.
Did you know that it does work for sound? Did you know it's just a relationship for waves in general? Isn't it weird that it would work for, all kinds of classical mechanical waves and mechanical mediums, and then it also holds true for light?
That's why we call them waves, buddy.
What's waving, Peter?
Well, depends.
No,
I don't know what's waving with you right now. But the reason why the speed is frequency times wavelength is because it's a wave.
Uh-huh. And it's, the ratio between those changes based on the medium. Like a wave in water will have a different proportionality between F and lambda than a wave.
Do you know why? Do you know why? Why do you think that is?
Because they're different mediums with different densities.
Yes, but why?
I just told you, they're different mediums with different densities.
No, give me the Y below that Y.
Why is the density of air different from water?
Why does it bother light?
Because the medium for light has a different density than air and water.
But what's happening there? Why does the light slow down, in quotes? Does it really slow down?
What are you talking about? I'm talking about the speed of a wave in a medium. If you know,
Yes.
okay, so if you know the wavelength and frequency, you can multiply those together and get the speed. That works for light, that works for sound, that works for waves and water, all the same.
Yes, and I am asking you, what is the physical explanation for why light propagates slower in, let's say, air or water?
Because of the refractive index of the material.
But why?
Because it is being attenuated through the material.
Give me the why underneath that. What is the quantum mechanical explanation for why that happens?
There is a loss of energy when it passes through the material. That's not a quantum mechanical explanation. That's a classic explanation.
So what is happening to the photons?
There is no such thing as photons, Peter.
Wait. Peter's boring. I see
Thank you.
Flipper down there. You guys want to talk to him? Remember how he was on Red's Rhetoric and then became like Homer Simpson in the shrubbery and disappeared into the background, like as if he wasn't even there? I remember him.
Oh yeah, let's get Flurf. Yeah, let's get Flurf Herder.
Pepperidge Farm remembers Flurf Dirter.
Actually, it's just a little after 2 my time, so I'm going to be calling it right about now, guys.
Good night, Stone.
That's fair. Flurf Dirter will not be bringing any gravy for you, so
Yeah.
this is a good exit time.
It's been a slice, y'all. We'll catch you next time.
Thank you, Stone, as always.
Later, Stone.
Good night, buddy.
See you then.
I'm gonna appeal to Stone several times tonight.
So, you know that there's another equation, Shane, where it's not, you know, the one I just gave you for velocity, but it uses the velocity. It's for the energy of a wave, and it's 1/2 the density, okay, times the velocity squared times the amplitude squared. And that's for a surface wave, for a ripple in a fluid, okay, without the effect of like gravity pushing it down, just on the surface, horizontal. So once you have the velocity, then you take the amplitude into account alongside the velocity to get the energy. And it's in contrast to the density. So there's just like how much velocity you have, which is the velocity is the multiplication together of the wavelength and the frequency. So when you have velocity, you have those two. So you got wavelength and frequency. Then you got amplitude. The only thing you have missing for the energy is the density of the fluid. So were you to take some, I don't know, measurements and plug these in, there would only be one unsolved variable, and it's the density of your fluid. It'll yield the density of your water, and it'll yield the density of your air if you use water waves or sound waves. This is the principle upon which sonar works. This is they use this for sonar.
But since Stone left, let's argue Stone's position. We're ascribing mass to the background medium as a density ratio.
Well, here's the thing. If I'm able to take measurements of the light and I adjust all these variables for light, the frequency, right, the wavelength, the amplitude, and I know that the velocity is constant, you know, light will be ever so slightly slowed down, but it's very negligible in air. But let's just say that, you know, we even took the air away. You did it in a vacuum chamber. I mean, if I was to measure these things, if you were to measure these things and you elucidated the same value for rho every time, which is the density, E equals 1/2 rho velocity squared, amplitude squared, If that happened and it came back as a constant, what do you think it would tell you?
The overall density or average density of the background medium.
Yeah.
Interesting. Now, how would you derive, say, a constant of that relationship? Then would you take repeated measurements?
Yeah, you would just take many measurements over and over and over, getting different amplitudes, different wavelengths, different frequencies every time. And you would measure the energy every time. And you would plug everything in. The only thing that would be left would be the density variable. And if it comes back about the same every time, you have a constant.
Boom. Now, in the case of ether, or like, a vacuum chamber remove all the air density, then it would be very, very thin, right? So it'd be a very, very, very small number.
You're saying that it would be very thin because light doesn't transfer a lot of energy based on, all this stuff. Yeah, I mean, there's a there's a no way to say that I can tell you the answer to this question without taking the measurements. But I'm saying my point is I think that it would work like that. I think that's my prediction, right? If my model is correct, then that's what I should see. So that's my hypothesis. All
I
I
have a
need is measurements.
question. You made me think right now. Genuine question. So if light travels with speed, let's call it c1 in air, then it enters water and travels with speed c2, slower than c1.
Uh-huh.
Then you said that that was because of something to do with loss of energy.
Snell's law. It's
Okay.
refraction.
Okay. Good. 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 And then, so is it because it's losing some energy in the water? Is that what you think?
The refractive index, every material will have a refractive index based on its rate of attenuation.
Yeah. So what happens inside of the water? It slows down because.
Because it's attenuating it. Do you know what attenuation is?
No, tell me.
Attenuation is energy loss.
Okay, so it's energy loss. Got it. So it goes in the air with C1, then in water with C2, and then when it exits the water, it goes with C1 again. How is that?
Because it's back in the new medium again and it has a different rate of attenuation again.
But didn't it lose some energy in the water? Shouldn't it just be slow now, kind of sluggish after it exits the water?
Oh, you're saying like the total energy being carried. I see what you're saying. For me, I think it's the crystal structure, like the crystal lattice structure of the geometry of the material. And so, because light's a wave, it has like based on the lattice structure, it bounces around in a certain way, and based on like the geometry of the structure inside, how many bounces, how complicated is this internal structure, determines how much slower the light is because it takes that much longer to get through the material.
So it's not losing energy?
Yeah, I wouldn't. Yeah, I mean, there's some energy loss due to heat. That's like where the energy loss would happen, but it's very
Mm-hmm.
negligible for light beams. For other different things, like I mean, okay, for a laser, for example, use like a laser. When you have a ton of energy, right? Based on the material, it will only have a certain capability to transmit it with respect to time. So once that's exceeded, the material begins to take on the energy itself.
Yeah, but where I struggle is that in reality, when there's something with a certain kinetic energy and it enters a denser, let's say, medium, slows down. When it exits that medium, it doesn't magically speed up unless it has an engine attached to it. So, what causes the light to regain its speed after it exits water?
Well, like I said, it's not actually losing energy unless the thermal thing happens, but it's when the I mean,
Yeah, I'm here.
it's the rate. It will lose some energy.
Oh no, what happened? Oh, it crashed out. Dang. All right, well, let's see what happens here, boys. All right, while we're waiting, we'll listen to some background music from Toby.
I think Nick Cage fell asleep.
There you are.
Who
All
killed
right.
the space?
Yeah, I moved you from your own private room, which I don't think you meant to be in.
No, nobody killed it. It was it just died or whatever.
The coast.
Nick
What happened
Cage
to
isn't
Nicholas?
asleep still. Oh, did Neon kill it?
No, he was up. It just the space crashed.
Oh,
Yeah. So I'm saying I don't think the host just quit it in the middle of our conversation.
No.
yeah.
no.
Well, to me, that's the same. Like him ending at a rich, mysteriously ending. Like
Dude, I'm
it's
gonna
just
roll
like,
with it right now. Though. Hold on,
eh.
dude.
No,
The
he
reason
wouldn't
that
do
the refractive index happens is because it's based on the molecular structure. Like it's like lights bouncing through like a hall of mirrors.
Nah,
And
what? Pizio, the impedance of the material is different, right? So it's just an induction rate based on the material that it's in.
yeah, but that's the light is passing through matter, right? Because water's matter.
Right.
So how's it going through the matter? It's having to slip in between the cracks. It's bouncing around in there.
I mean, that's what
And
they say
so
as a particle. Just the quantized chunk of energy. That's what they say.
it's a wave moving through there, and depending on the structure of the hall of mirrors that it's in, aka the matter, it will determine how long it takes the light to bounce around in there to get out to the other side. And that is, your refractive index. Let's see.
I think you
What
just
determines
conflated two models, dog.
the refractive index of a material?
It's magnetic permeability and electric permeativity.
Right, but what determines that? It's just a constant for each material. It's unique for each material.
Well, it depends on the
if I
wavelength too, right? So that's what they did the measurements with to get the refractive index for everything. They just so like when you shine light through it, it makes a certain interference pattern. So like it's literally, in that medium, it's slower. It's just oscillating, or the induction rate's slower in that medium. They just measured it through that, like through fringes. No
I know
fringes.
I know what it is, but I'm saying what causes it to be what it is, right? What causes the refractive index for water to be what it is and for air to be what it is? Like why is air's the number that it is and why is water's number the number that it is? Why isn't it a different number? Why is it that one? So it's related to the electric susceptibility of the material. It's this cursive X symbol. And the refractive index squared equals 1 plus 4 pi times electric susceptibility. It determines how easily the material's electric dipoles align within an external electric field. For non-magnetic materials, this is the approximation used, where XE whatever the X is, it's like cursive X, describes how the material responds to the electric field of light. Okay, so I got you. Material, here, let me get this big so I can try to get the whole thing. All right. All right, here we go. Bam, right there. So when light enters a material, its electric field induces oscillations in the electrons. That's what they say. The ease of which with these electrons can be displaced or polarized, how easy is it to move them, affects how light slows down and bends. Materials with different electronic structures have different polarizabilities. For example, materials with more free electrons or specific types of bonding can interact more strongly with light, leading to higher refractive indices. The refractive index is related to electric susceptibility, X sub E of the material. It measures how easily its electric dipoles align with an external electric field. There's the equation, and it says the density of the material and the nature of the bonding between atoms or molecules can affect how light propagates through it. Higher density and strong bonding typically increase the refractive index. The refractive index can vary with wavelength due to dispersion, where different wavelengths of light interact differently with the material's electrons. This variation is due to how the material's polarizability changes with wavelength. So the wavelength affects the material's polarizability. It changes with the wavelength. Different wavelengths of light, because a stream of light, unless it's polarized, unless it's like a laser, will have several different wavelengths, right? And together, right? It'll be like, imagine a bunch of different waves like layered over each other, right? And it will travel like that, and each one of those different sections that's a different wavelength within that layer of strings of light will have a different rate of propagation through the material, a different dispersion, a different refractive index. So refractive index is dependent upon wavelength. So like I said, when the wave goes through there, it bounces around. This is kind of like when I talked about the photoelectric effect. Dependent upon the wavelength of the wave, it'll be able to slip in, right, and get through like a certain, like a path that's previously blocked off when the wavelength was too big, frequency was too low. So the light's going to take the path of least resistance. All current always does that. It's just like it can feel its way through based on like potential differences in the pressure in the medium, and based upon its wavelength, it, like if it's got a shorter wavelength, it'll most likely be able to make it through there quicker. It's interesting to think about, dude. I think that when you really start to take this wave thing to like its full like logical conclusions, like it fits in so many things. Using freaking wave mechanics, classical wave mechanics equations for like electricity, dude.
It's illegal.
Yeah, well, the velocity equals frequency times wavelength thing held true.
Dang nabbit.
Pretty wild.
Well, that was a good salvage from what would have been disaster and boredom.
Yeah, I'm gonna end stream. So
Yep.
Good night, lads. Thanks for tuning out or tuning in or whatever you did.
Tuning out, tuning in.
You did something during this time, so thanks for doing that. And we'll see you on Monday for research and reading night. Then that'll be followed by Tuesday's presentation, which will be a group
Something.
study. It'll be a group study sesh on how to do, or on how we do research. Kind of show the tools we use and all that kind of stuff. So we're going to be going in depth on that, and then taking questions and stuff. So if you want to start taking your own notes and organization and etc., this should be a great breakdown for that.